Hello everybody, it's Miss Austin. I'm going to be going over the Unit 6 Lesson 4 practice problems. You might be doing these on Desmos or in your book or on a digital PDF. Number 1, match each equation to its description. So today we figured out the equation of a circle, and I'm just going to write that at the top of the paper. It's x minus h squared plus y minus k squared equals r squared. And hk is the center of the circle, and r is the radius. Okay, and that was in the lesson summary, but I'm just kind of recapping that on the top. Match each equation to its description. So you could either look here and find it here, or figure out the center and the radius and go over here. I think I'm going to look at the equation. So the center on this one is 1, and then no movement here, and then the radius is the square root of this, because this number squared made that. So what's the square root of 9? 3. So a center at 1, 0 with a radius of 3. This guy's D. All right, this one, the center there's no movement here. And this one, it's a positive. The formula is negative. That means that was a negative. Minus a negative made a positive. So center's at 0, negative 4. And again, radius of 3. There's letter A. What do we got here? Center 1, 4. And this time, what number squared made 3? Well, what's the square root of 3? The square root of 3. The radius is the square root of 3. So 1, 4 with a radius of 3. This guy is C. What do we got here? 1, that's a positive, means it's negative. So this is 1, negative 4, square root of 9, 3. 1, negative 4 with a radius of 3. I'll put them over here. And that leaves this one. Let's just make sure it's right here. D, A, C, E. The center is 1, negative 4. The square root of 3 is the square root of 3. D. Okay. Number 2. Write an equation of a circle that is centered at negative 3, 2 with a radius of 5. So remember, if you look up here, it's x minus the x coordinate of the center. So it's going to be x minus a negative. When you minus a negative, that becomes positive. Plus y minus the y coordinate equals, and then this number here is the radius squared. So 5 squared is 25. Which one of those matches? Plus 3 minus 2, here it is right here. Plot the circles x squared plus y squared equals 4 and x squared plus y squared equals 1 on the same coordinate plane. Those of you doing this on Desmos, it was a little bit easier. If you get a piece of graph paper. So this is centered at 0, 0. And that's the radius squared. So to get the radius, I take the square root. So the square root of 4 is 2. So 2 this way, 2 this way, 2 this way, 2 this way. Not perfect, but it's okay. And then the next one, do it in a different color. X squared plus y squared equals 1. So still centered at 0, 0. What's the square root of 1? 1. 1, 1, 1, 1. Okay. So there's part A. Part B, find the image of any point on x squared plus y squared equals 4 under the transformation xy becomes 1/2 x, 1/2 y. That means I'm going to divide the point by 2. So my eyes gravitated towards that point right there, which is 0, 2. Now I'm supposed to cut both of them in half. So that would become what? Well, half of 0 is still 0, and half of 2 is 1. That's that point right there. What do you notice about x squared plus y squared equals 4 and x squared plus y squared equals 1? Well, they're similar circles. I mean, this is just a dilation. You could go either way. This middle one, this pink one, is a dilation, scale factor 1/2. Or you could go the small one to the big one, it's been doubled. They're similar. This one is just a dilation of 1/2. All right, number 4. xy becomes x minus 3, 4 minus y is an example of a transformation called a glide reflection. It's got a slide and a reflection. Complete the table using the rule. Does the glide reflection produce a triangle congruent to the original? So it says take 3 away from the x, and then I think it's easy, just look what this says. It says 4 minus y. So whatever y is, I'm just going to do 4 take away that. So look, so 6, I'm supposed to take away 3 from this. So 6 take away 3 is 3. And then it says 4 minus the y coordinate. Well, the y coordinate's 1. 4 minus 1 is 3. This one, I'm supposed to do 3, this number take away 3, which would give me 0. And then it says to do 4 minus the y coordinate, -1. And I said, would it be congruent? Well, which transformations produce congruent figures? Translations, reflections, and rotations. And this is a combination of a slide and a reflection, which are both rigid transformations. Yes. Because it is a translation and a reflection. They're both rigid transformations. Number 5. The triangle whose vertices are 1, 1, 5, 3, and 4, 5 is transformed by the rule xy becomes 3x, 3y. Is the image similar or congruent to the original? So this is a dilation because both x and y have been multiplied by the same amount, which produces a congruent? No. Similar? Yes. And it's not neither. As long as both the x and the y are multiplied by the same amount, that's a dilation which produces a similar figure. Number 6. Match each coordinate rule to a description of its resulting transformation. And this is kind of going back to how we started out talking, to then how we learned how to talk with the input and the output. You could look here and then look for the match. You could look here and then look for the match. I'm going to look here. So I see, like, look, -3 in the x, no change in the y. -3 in the x, no change in the y. This guy's D. No change in the x, -3 in the y. No change in the x, -3 in the y. This is F. Add 3 in the x, no change in the y. Add 3 in the x, no change in the y. Add 3 in the x, no change in the y. There it is, E. Okay, no change in the x, add 3 to the y. No change in the x, there it is, add 3 to the y. 3 in the x and 3 in the y. Positive. Take away 3 from both the x and the y. Dilate using a scale factor of 3. That's where you're multiplying them both. And we are skipping number 7 because it's from a lesson we did not study. Hope that helped. Have a great day.